Alrighty, a little late, but let's see if I can do this. Compare version numbers. Medium problem, given two version strings, version 1, version 2, compare them. A version string consists of revisions separated by dots. And the value of the revision is its integer conversion, ignoring leading zeros. To compare version strings, compare their version values left to right order. If one of the version strings has a few revisions, treat the missing revision values as 0. Just return if version 1 is less than version 2, return a 1. If it's bigger, return 1, otherwise return 0. So 1.2 and 1.10. So this one is smaller than this one, so therefore it's negative 1. 1.00, this is basically 1.1 and 1.1, so they're the same. Ignoring leading zeros. This is also the same because, okay. Interesting. Okay, so first step is just doing the conversion from the string to like an integer array where the elements are each number that is dot delimited, dot separated. So I think that would be maybe v array 1 is going to be, I think I use the split operator. Split the version string and then convert that to a integer array. Once you do the split, that should be splitting it into substrings. So when you convert that substrings of integers to actual integers, so it'll be a list comprehension integer of k for every k in the substring array. And let me double check that this is working correctly for the various types here. I thought I did the split. Oh. Oops, I think I did split wrong here. I think it might be the string dot split, right? String dot split and then the delimiter or the character split version. So I have this backwards. Using like join, that type of formatting. Alright, 1, 2, 1, 1, 1, 0. Okay. Do the same thing for version 2 string. Int k for every k in this other array. And I'll verify this is correct. 1, 2, 1, 10, 1, 1, 1, 1, 1, 0, 1, 0, 0, 0. Okay. And then it's just simply a matter of iterating over the integers within each array. And if one is smaller or bigger than the other, then that breaks the loop. So I guess I can probably iterate over just arbitrarily the first array for every part in version array 1. If this doesn't exist in version array 2, then that means that doesn't necessarily mean that it's not equal, because they could all be zeros afterwards. then I would treat it as 0. I would need to just treat the version array 2 as 0. Okay, so I'll say the compare value for the other is going to be 0 if, okay, I think I'm going to use indices here. Where n is the length of the number of parts in the first version string. So I'll say P1 is going to be, so P1 is part from string 1. It's going to be the array 1 at this index. And let's say P2, the thing that is in the comparable spot in the other string is going to be 0 if this index is greater than the length of that string, else it will be whatever it is at this index in the other string. And if P1 is less than P2, return -1, else if P1 is greater than P2, return 1, and then this iterates over everything and then returns 0 if it doesn't. This seems a little slow. There's a lot of if statements there, but this probably should be pretty fast. Index out of range. Really? Guess this should be greater than or equal to. Oh boy. Oh, I see. Yeah. Yeah, I see. So this thing terminates after just doing the first comparison of the first part, and then needs to actually compare later parts. Okay, what's the quickest way of fixing this? I think maybe I could go index. I could go index as the maximum of the two lengths, and then use a 0 if the index is greater than the length of that particular string. Alternatively, I could just append zeros to the array that is shorter, and then I have to worry about this check later on. Alright, let's do this. While length of the array 1 is less than length of the array 2, the array 1 pends a 0, while length of the array 2 is greater than length of, guess maybe I can do, can I do is there a function that extends an array to a certain size? Extending with a specific field value. Okay, extend times the list dot extend parentheses 0 times the number of elements to add. Using a pen and a loop, which is fastest. The fastest way to extend to specifies involves using a list, multiplication, and slicing. Okay. So the fastest way of extending with the multiplication. Okay. So I say if length of the array 1 is smaller than length of the array 2, then I'll say the array 1 dot extend 0 times the difference. Else, if length of the array 2 is greater than length of the array 1, the array 2 let's see. The array 2 extend 0 times the difference length of the array 1 minus length of the array 2. And then I can just ignore everything about checking for lengths. They should be comparable at that point. They should be exactly the same at that point. So for every value, or for every p1 in, or value 1 in the array 1, if value, no, I need I need indexing, or every, let's say n is the length of the array 1 at this point. For every index in range of the array 1, if the array 1 at this index is smaller than the array 2 at this index, turn -1, else if the array 2 at this index is less than the array 1 at this index, turn +1. This object cannot be interpreted as an integer. Whoopsie, this should be in range of n. Okay. That was pretty simple, I think. Just need to hammer out. I mean, that one bug is, that first error that I got was pretty bad. Like, I should have figured out that that was going to be an issue. Okay, so conversion. You'd probably just do something like just put in one. I'll say this is subs1, like substrings 2. I could probably do this in one line, but I think it's a little better to decompose this anyways. And then, I don't know if the v helps at all. I can just call this array 1 and array 2. I think that's pretty apparent that they correspond to be the version strings. Would use variables for the length of each originally, maybe. It is a little verbose here. Sure, let's use some variables. Let's say n1, n2 is the length of array 1, length of array 2. So if n1 is less than n2, array 1 extends by n2 minus n1. Else, if n2 is bigger than n1, or n2 less than n1, then it's the other way around. And then this is the updated length. And then iterate over it. I think this is generally pretty fast. If you didn't do this extension, you'd have to do an if statement here where you constantly check whether the indexing is like past the end of the length of that string that you're trying to index into, or past the length of the array that you're trying to index into. So it's like skip those extra conditional checks in this for loop, but you have to force extend it. So space-wise, this is going to be a little longer, but maybe speed-wise it's still faster. Okay, so summary. This is not too complicated in terms of logic. Most of the problem is kind of, to me, is calling the appropriate string / array / list methods to convert the dot separated or delimited. Is it delimited or separate? In the phrase 1, 2, 3, commas are delimiters. Okay, delimited. And you can also call it, like CSV is like comma separated values. So I mean, I guess that separated is also fine. Dot delimited values in the string to an array of substrings of ints, and then convert that to an array of integers, right? That's this first bit, splitting it, use split and list comprehension for that, and then to make comparison easier, putting need for constant checks about length of those arrays can use extend to force both arrays to have the higher number of values. So that's this thing here, extending with a bunch of zeros into the array that has less values. Finally, iterate over values using index in a for loop and do comparisons with return logic. Return 0 if all comparisons fail to return a difference. All right, time complexity. This is going to be O of n. Let's convert the strings to arrays and arrays to integer arrays. Also O of n to do the later comparisons. Basic complexity, this can be O of n as this method does create arrays of integers. It's possible to create a version of this solution where, or to create a solution where comparisons are done done with string values at a time. So not making an integer array, like somehow parsing the string by each dot, I guess. In which case, the space could be lowered to like O1. So if you actually, instead of doing the split and conversion to integer arrays, you actually parsed it character by character and like parse the first string to the first dot, parse the second string to the first dot, convert those things to integers, and then do the comparisons of those integers without having to store the array of those values, then yeah, it could be smaller, which makes sense because I think my solution was in fact on the higher end of some of the other solutions maybe. Yeah, there could be some solutions that doesn't do the array.